So what is the Amphicar? The Amphicar is an RC car that can drive in both water and on land. And so those wheels were something that we put a lot of time and effort into, and they're actually good for like land terrain, even with a little bit of slip, and then also for water, and that's what propels the car in both surfaces. So our inspiration came from one of these duck boats, and Sean's going to jump in and talk about it.
So in World War II, U.S. military used DUKW boats, which were made by GMC, and they're amphibious transport for troop and supplies. A lot of you guys, if you travel to Boston or any of the coasts, you may see these used as tour boats. So I actually have been on a duck boat in Boston years ago, and they take you around the city and like see all the different landmarks, and then they say, okay, we're just gonna drive straight in the water. So they drive straight into the bay and then actually like go around the city. So it's a really cool experience. I know as a kid I loved it, and that was kind of like our design inspiration for that. And we also wanted to tie in some Purdue school spirits, so our color scheme obviously matches that. So it's kind of our design inspiration is to have something that's both amphibious and land-based that's remote controlled.
So while I show you guys some of our models of the duck boat, I guess, why would somebody want a duck boat or an Amphicar? Well, so there's a market for both RC cars and RC boats. And if you have a lake house, or you're going to the beach, or going to the pool, you don't want to bring both of them. So with this, you can just bring one Amphicar, and it's good everywhere. So that's pretty cool. And there's a picture of our model. So play value is pretty good. You only need one RC car or one Amphicar as opposed to two different RC boats and cars. Also, our target audience is children, usually interested in robotics or really whatever, or just people that like remote control cars. It can be the color scheme can be changed for both boys and girls depending on what they're looking for. So.
All right, so this is a demonstration of it in water. We did land demonstrations before this, and it was successful, so we threw it in the bathtub to see how it went. As you can see, it turned out pretty well. There it is moving around. We would like to take it to a pool sometime and test it in a more expansive area. But, only at that.
All right, so obviously one of the critical components of this is the wheel design, because we need to be able to both drive on the land and aquatic terrain. So figuring out like the balance for the different design criteria was kind of important. So you can see some of our previous iterations here, and obviously everything was kind of a paddle design. So everyone's seen paddle boats, like the big steamer paddle boats before. So we were trying to figure out, how can we integrate what's already been made into our design. So you can see paddles on the outside, paddles on the inside, and we're just not sure how well that was effectively going to trap water so we can get effective propulsion. So we kind of scrapped these ideas and then went to prototyping and just kind of started playing around. And on the next slide, you can see a video of a very poorly made styrofoam copy of the wheels that we're doing here, if we can get it to play. So you can see Serge is just spinning it in the water, and it's a little hard to tell in the video because my phone's terrible, but what actually you can see was the water splashing up. So we knew it was catching water with the design, but we didn't really know exactly how well it was going to do that until we decided to print it. So we went ahead and went on to the CAD modeling of it and made some modifications. A couple key features I want to point out. First, for land movement, you can see we've got pretty deep treads, which should help us get grip, especially like on a carpeted surface. It's pretty easy to get pretty good traction without having some sort of rubber wheel on it. Second thing, you can take a look at our paddle design, which is really the critical component. We decided to go with 3 paddles on it that are bidirectional, so the vehicle can move forward and backwards. You can see the symmetry, lines of symmetry through it. Paddles are also designed to catch the water, so they come inside, which you can kind of see on the vehicle itself. There's a lip here that more effectively traps the water. And then also, obviously, we have to be within the design criteria for 3D printed space. So we use about 12 or 13 cubic inches of material for this.
All right, so this is the mechanism. We used cheap 5-volt DC motors to power this, and then we used a gear reduction system to get the necessary torque on our wheels. There's actually 4 gears there, and they're kind of hard to see. But the motor is going to drive this gear here. It's got another gear, which is gear 2, gear 3, gear 4 into the wheel. And okay, so I'll just summarize. So when the motor spins, there's about a 40-to-1 reduction, which gives us the necessary torque at the wheel.
I will briefly discuss the electronics. As you can see, there's a lot of components in here. We use the Arduino Uno to control basically the logic from receiving the signal from the transceiver to the receiver and how to read those values. These are the transmissions that Caleb talked about. These are the gears, and the motors are running that inner gear, and based on the configuration, it's a pretty cheap transmission, so the gears aren't quality. We've had some slippage, but there's multiple different configurations you can do depending on torque and the RPMs we wanted. I think we went with yeah, it was like 36.5. Okay. So it wasn't the highest RPM, or we wanted some torque in the water, but we also didn't want this thing to not move. That's fun. This kind of removing the shell. We have 2 transmissions, and then this is the motor shield, which gets input from the Arduino. Okay. So originally the top one is the receiver, and that's what gets the signal from the transceiver. The receiver sends the input values to the Arduino, which processes that, and depending on what the states are of the control, it powers the motor controller. The motor controller is crucial here because we want it forward and reverse. I'm sure most of you guys know that DC motors can only go one way unless you physically switch the wires. So that's basically what the motor controller is. It's an 8 bridge. So it allows current to flow one way and then switch the polarity and go the other way. And then we're also powering it up with 2 9-volt batteries. We did that just because of saving space and weight.
Okay, so some design obstacles. All the electronic components are pretty heavy, so the vehicle's a little bit larger than we originally intended, but we were able to still compensate that with the large enough wheel to keep the vehicle moving. It was also pretty tough to find quality electrical components that were within our budget. We also needed to make sure that water wasn't going to leak through the axle holes into the body of the car and fry the electronics. So in the future, we would have loved to be able to 3D print our body. We would have been able to get maybe a more ideal shape to flow through water, and also do a little testing with some larger wheel sizes to see if we could get that thing moving a little faster in the water. So, are there any questions? Actually, before we do that, let's test this thing in the water.
Maybe we should do that while we ask questions.
That's fine too.
What's the intended use environment? So you take this out with your family to wherever. What's the actual terrain it's riding on?
We're planning for it to be just about anything, honestly. So it's a little difficult with this prototype due to the size limitations. We're hoping for just about any terrain. So it could be on grass, it could be on cement. But to take your kid to the park, right, or to the pool. So the ideal environment would be able to drive like off the edge of the pool into the pool and like through the water. So just kind of multi-terrain.
How does it do on sand?
We have not tested sand yet. So I live close to Lake Michigan. I assume we're gonna have a lot of difficulties with that. Just from even walking in sand can be difficult at times. So that's something that we would have to check.
Okay.
What terrains have you tested it on besides?
We've done hardwood floors. We've done carpet. We've done obviously water. Those
Have you
are
done
the-
grass?
We have not done grass yet.
Or like
Right now, we have some clearance issues
Okay.
due to the wheel size and the buoyancy of how big we have to make the body. So, right now you can see it's a little difficult because our tub's a little small, but we are able to rotate it within it. We are able to move it forward and backwards. Also, the question in the back.
Have you done any transitions from grass to water, from water to sand or anything like that? Because I see
We've
that
gone-
you pick it up and you put it in the water, you pick it up and put it on the land. Have you ever done transition?
We've gone from like hardwood floor to carpet, and then we tried to take it over like a door, you know, the bottom of the weather stripping on a door frame. It did get stuck, so clearance issues is probably something we want to address.
So I don't know if you ever seen a truck back a boat into the water. Some people can be.
A little difficult.
Yeah.
The issue is that the swimming pool at the apartment complex we were doing all the things was actually empty, so we couldn't test it there, and then we weren't allowed to take it to the co-rec to test it, and it's a little hard to drive into a bathtub. So we weren't able to do the testing that we wanted to do, and that would be on the next stage for future considerations.
Good question.
Thank you.